Okay, now I'm gonna do a review on complex number and how we can use the complex number. The complex number, basically, when we talk about the complex number, we talk about the number that they have the real part and the uh, imaginary part. Uh, and I will show you what I mean by that. The very first format of the showing the complex number is to use the rectangular form. So the very first type of the complex number, basically we show the complex number in different format. The base form that most of us are familiar is the rectangular form. Uh, so the rectangular form is that we write the complex number as um, z is equal to the x plus jy. Uh, and when we write it like that, we'll say that the x that we have here, x is the real part of that complex number. So it's the real part. Y is the uh, imaginary part. Uh, and then the j. And maybe in the math or the other classes, it's usual they show it with the I. In the circuit, we show it with the J because we use the I for current to just prevent confusion between the current and that the imaginary number. We use it as a J. And the J is imaginary, they call it imaginary number. And is equal to a square root of -1. So j is a square root of -1. In other words, j squared is -1. So anytime that we have the j squared, it's going to be the -1. This format is called the rectangular format. And why is that? Is that if I go ahead and um, assume I have a axis and I show that the real part on the horizontal axis and the imaginary part in the vertical axis, the z would be shown with something like that. So it's going to be the z. This vector format is going to be the z, and then the projection of that on the real one, this part is going to be x, and this part along the imaginary line is going to be y. So here, if x is 0, then the z is become jy, and basically what I have is the pure imaginary number. If y is 0, then z is become equal to x, and then what we have is the pure real number. If none of them are 0, then I have the complex number, as I have here. I have the x and j and I. So now look at here. Yeah, one other thing that I want to mention here is that if I go ahead and let me draw that real and imaginary. Okay, so it's going to be the real and it's going to be the imaginary. Now if I have the let's make it a little bit shorter here. No, that's going to be the real part. Now if I have, it's going to be the z, it's going to be the z, and so it's going to be the x, and it's going to be the y. Now if I just go ahead and have another one right down here with this the same x, let me use another color. If I have another one goes down from here that has the same x but the y is going to be negative y, so it's going to be negative y. Let me put this here also, and this is going to be y. So this one is x and y, this one is x and negative y. So what I'm going to have is that I have, and this one I call it no, z, and we use the star. Then z is going to be x plus jy, z star, down a little bit lower, z star is going to be x minus jy, and is it calls the complex now look at here, the whole point is that if I have this one, I have this one, if I go ahead and say z times z star, what I'm gonna have is that is gonna be basically what is, if I do that and times these two, so we're gonna have x plus jy times x minus jy, and it's gonna becomes x squared minus, if you do the calculated, j squared y squared. And look at here, the j squared is -1. The j squared is -1. So z times z star is going to be x squared plus y squared. X squared plus y squared, which is, if you look at it, is the length of that x squared plus y squared is the length of that vector, the power of 2. So if I show the length with this, is basically is the length of that, the power of 2. So if I go ahead and say the length of that array is z. Sorry, the length of that arrow is z. The same here, the length of this one is going to be the z as well. And this is how they usually use the lengths in the complex number. So they just put the absolute sign on two sides of that. So know that if I times the z by z star, it's gonna gives me the length of the magnitude of that complex number for me. And I'm gonna also write it here. So in this case, the magnitude of, so this is the complex number, and the magnitude of that, if I want to know, so the magnitude of z is usual root with the like that, as I said, the absolute values is equal to root mean square of x squared plus y squared. So I will talk about it a little bit later. So this is the very basics of the rectangular form. From all these things that I write here, probably the part that you want to remember is this and this block. And the j is -1. The rest probably is not that important. So this is the rectangular form. The j is the square root of -1. And this is how we show them in the real and imaginary axis. When we want to do the calculation with a rectangular form, we will do it the same way that we will do it for in the similar mathematics, the regular mathematics. So let's I would say that I have the two complex number. The z1 is 5 plus j5, and z2 is let me write it off there, and z2 is going to be 3 minus j4. So assume I have these two complex numbers, and I'll show you how we will do the calculation with that, the arithmetic calculation. So z1 plus z2, I will see what happened here. So simply just do it as you do it in, so we have 5 plus j5 plus 3 minus j4, and then add the real part together, add the imaginary part together. So if I add the real part together, it's going to be 8, 5 plus 3, and if I add the imaginary part together, I have 5 negative 4, so it's going to be 1 j. So this is how we add it. So just simply write it in the rectangular form, add the real part together, add the imaginary part together. Similar to that, if you want to do the subtract, also the same. So z1 minus z2 is going to be 5 plus j5 minus 3 minus j4. Again, you subtract the real part and subtract the imaginary part. So if you subtract the real part, it's going to be 5 minus 3, so it's going to be 2. And if you subtract this one, so it's going to be 5. Then in negative is going to be plus, so it's going to be 9. So it's going to be j9. So you do that. When it comes to multiplication, to multiply them or to divide them is going to be a little bit different. It's going to be another story. I will show you how we will do that in this rectangular form, but later on I will show you it's much easier to use another form rather than the rectangular form. So the z1 and z2, if I want to times them, to multiply them, so it's going to be 5 plus j5 times 3 minus j4, and then you have to just expand it and times term by term. So it's going to be uh, uh, 5 times 3, and then we have the 5 times the 4j, so it's going to be minus j20. Then you have this one, it's going to be 5 times 3 is going to be j15. And then you have these terms, the second term, which is going to be negative um, uh, j squared 20. And you know that the j squared is going to be negative 1. So you know that the j squared is negative 1. So then if you do the calculation and simplify everything, so add the real part together, add the imaginary part together, and simplify it, you're going to get, if I'm right, you should get the 35 minus j5. Just by knowing that this term is negative 1. So, um, uh, so eventually you have here plus 20 and plus 15. So it's going to be 35. And then you have here negative 20 plus 15. So it's going to give you negative 5j. For division, if I have the z1 divided by z2, what we'll have is going to be, I have 5 plus j5 divided by 3 minus j4. For division, it's a little bit more complicated. Not complicated, it has a couple of more steps involved into that, and is going to be that we are going to times it and divide it by if it's a z2 by z2 star. So basically, if I have 5 plus j5 and then I have 3 minus j4, I'm going to times it by, if this is a z2, then I know that the z star 2 is going to be 3 plus, so it just changed the sign of that. So if it's negative, it's going to be plus. If it's positive, it's going to be minus j4, as we had it here. So if this is a z, the z star, just the sign of the y is going to change. And the same, if this is a z, this is z star. So we just change the sign of the y. So here, I change the sign of the y. So it's going to be 3 plus j4. And then we have the 3 plus j4. Why we do that? Because now look at if I saw when I times this one and this one, so it's going to be the z times z star, and look at here, z times z star is going to be a real value. It's not going to be anymore a complex number, so it becomes a real value. And eventually, if you do the calculations, I'm going to just write them here. So you're going to have on here is going to you have 15 plus. So basically, this one is this, is the same as what we have up here. So it's the j20 plus j15 minus j square 20, and down here, what we will have is going to be 9 plus j12 minus j12 minus j square 16. Or you, instead of doing that, you can say that this one times this one is just a magnitude square, or simply just replace it with that. Or you can do the calculation. Eventually, if you do the simplification, what you are going to get, if you add all the real value together, all the imaginary value together, you're going to get negative 5 plus j 35. Let's see. Yeah, so, and then we'll have divided by 25. So let me make sure that I write this one. So 15, J20, J15, and this one is plus. Okay, this one's plus here. Then J20. And the 9, that's going to be plus. J12, then negative J12, and negative J16. So, yeah, this is what you get, and then you can simplify, just divide each part by that value. So it's going to be negative 0.2 and then plus J1.4. So divide the real part by that value and divide the imaginary part by that value. And it's what you get. Later I will show you it's much easier that do the plus and subtract, so add and subtract using this rectangular form, but it's much easier to do the multiplication or division using the other form of the imaginary number. So this is the very first part of that. So I start with the rectangular form. Now I want to go ahead and start to talk about other forms. So the next form that we will have it is going to be the polar form of that. So it's going to be second one is the polar form. So the complex number, when it comes to the polar form, it usually, if you have, yeah, if I have it like that, and it's the real part, and it's the imaginary part, and I have z like that, and the length of that vector is z, and the angle it has here is theta. In the polar format, I will say that the z z is equal to magnitude of z with the angle of theta. So this is how we will show them in the polar format. And again, if I come here and says this, look at here, if I come here and say this is the x and this is the y, so I can write that the z is going to be x plus jy, or it is equal to z with angle, the magnitude of z with angle of, well, let me draw this line. So this is z with the angle of theta. And what's the relation between these two? Is that we know that the z, the magnitude of z is just a simple arrow. So it's x squared plus y squared. So it's the magnitude of the z, and the theta, the angle here, is tangent inverse of y over x. In this triangle, look at here, it's a y over x. So the tangent inverse of y over x. And that we have it. Now, what's the magnitude of x in respect to that value that we have here? So if I want to say the so this is one word. So this is z as a function of x and y, and theta as a function of x and y. And now, what about the x? Look at here. X is the z cosine theta. So this magnitude here this distance here is just z cosine. Let me see if I can. This magnitude here is z cosine theta, and this magnitude here is just z sine theta. Again, remember when we have the vector and we have the theta and want to project it, it's going to be cosine for on the axis that is next to the theta, and it's going to be sine for the axis that is not next to the theta. So here, because theta is here, so the axis is next to the theta is the real part, so it's going to be cosine, and this one, because it's not next to the theta, it's away from the theta, so it's going to be the sine. So the same here, so I can go ahead also said if x is a z cosine of theta and y is z sine of theta. So these are the relationship between these two formats that we can write them. So if I go ahead and say, so if I have them like that, so you have the z is in the rectangular or the polar, and then this is how they are related to each other. So we can easily, if we have one of them, we can easily convert one of them to another one as we using these equations. So if we have the rectangular and want to convert it to polar, we just use these two equations. If we have the polar and we want to convert it to rectangular, we use these two equations to find the x and y, and simply we can convert them, convert one of them to another one, or the vice versa. So very quick example. Assume, for example, I have the z, which is gonna be 5 and with the angle of 30, and then I want to convert that to z as a format of x plus jy. How I will do that? It's usually much easier that you draw it, so it gives you some idea of what you are looking at. So it's the real part, is the imaginary part. So I have here it says that the length of the length of that is 5. So the length is 5. This is the magnitude of the z. So I know I can say, okay, the magnitude of the z is 5. So, and the angle is this theta is 30. Now I want to find the x and y. So I know that here this is the x, and I know that this x is z cosine theta, and this is the y, and I know that the y is z sine theta. So I can go ahead and calculate them. So I can say that, okay, x is z cosine theta, which is the z is 5 cosine 30, and y is z sine theta, so it's going to be 5 sine 30, and therefore the z in the rectangular format is going to be x plus jy, so it's going to be 5 cosine 30 plus j 5 sine 30. And if I have the calculation right, so it should come out as a 4.33 plus j 2.5. So this is how, for example, we convert it from the polar to rectangular. Similar to that, you can do the other way also as well. So assume as another example, assume I have the the z is 10 plus j5, and I want to convert that to z into the polar format, to the magnitude of z with angle of theta. Again, as I said, it's much easier to draw them. I'll look at that visually. So it's going to be the real part. It's going to be the imaginary part. And then if I have that, so I know it's going to be, so it's going to be 10 here, and it's going to be 5 here, and then I want to find the magnitude of that and this theta here to find it. So I know that, so the magnitude of the z, I know it's going to be the xx squared plus y squared, which is going to be 10 squared plus 5 squared. And the theta is tangent inverse of y over x, which is going to be 5 over 10. And then you can say, okay, the z is going to be the magnitude of the z and angle of theta, which is going to be the 10 squared plus 5 squared. It's the magnitude with the angle of tangent inverse of 5 over 10, which, if I'm right, is going to become 11.18 with the angle of 26.57. Just one point about the tangent is like that if you have, just I'm giving you an example here, sometimes, for example, if you have 5 and negative, instead of having a 10 and 5, assume you have a negative 10 and 5. So assume that the z is going to be negative 10 and plus j5. If you draw that, you will see that if it is going to be the real one, it's going to be the imaginary one. If you draw that, it's going to come out somewhere here. It's going to be look like that. So it's going to be negative 10 and it's going to be 5. The problem with this one is that if you go and calculate, so this time the theta is this. This is the theta. So it goes from here to here, from the real. But if you calculate the theta here, what you are going to get is that for this case, the z is going to be the same as what we have here. So if it is the z is not going to change. So the magnitude of z is going to be, this time is going to be negative 10 to the power of 2 plus 5 to the power of 2. But if you calculate the theta as a tangent inverse of negative 5 over negative 10, it's going to give you negative 26.57. But if you look at that, the negative 20.57 is actually here. This is the negative 26.57. So to get that actual theta, you have to add 180 degrees from here. You have to go 180 degrees to get the theta. So you have to add 180 degrees to this theta that we get here. So sometimes when you do calculate the theta, you have to either add or subtract the 100. So actually the theta is going to be negative 26.57 plus 180 degrees, and you can find it visual when you draw that. And this is one of the reason I said is really good that you draw that. When you draw that, you can actually see what you calculated, and if you see, for example, it comes as a negative and you know the theta is there, so you can easily look at that. To get from here to here, you just have to add 180 to get to here, to have the correct angle. Remember that this equation might be 180 degrees off. So when you do the calculation, remember that. So this is the polar format that we have, and we have the rectangular format and the polar format. The other way that we may write the complex number is into the exponential form. So the 3 will be exponential form. So in the if we have the rectangular format of z is x plus jy, is the rectangular format, and then we have the polar format is z as z and with angle of theta. So it's the rectangular is polar. Then we will have the exponential format is going to be z as the magnitude of the z. It's going to be e to the power of j theta. This is going to be the exponential format of that we can write it. And we know that here we know that the e to the power of j theta can be written as cosine theta plus j sine theta. This is what we know. So therefore, I can go ahead and say that the z also can be written as the magnitude of the z cosine theta plus j magnitude of the z sine theta. So this is how we use the exponential format. So if I want to go ahead and put all these formats together, so before doing that, let's me and to calculate it, for example, from the polar or the rectangular to get this is very similar to all we have up to this point. So for example, assume I have the z is in format of the polar of let me write it a bit higher. So assume I have the z is equal to 10 with angle of 60. So if I want to write it with all these format that I have, I talked about them. So I can write it in the rectangular format, which is going to be the uh, x plus jy, um, uh, as I have, which is going to be, the x is going to be uh, z cosine theta plus j sine theta plus j z sine theta, and it's going to be 10 cosine 60 plus j, and the z is 10 sine 60. So it's one way of that I can write it as the um, rectangular form. To write it as the um, polar format, as exponential format, is going to be z e to the j theta. So the magnitude of z I know is 10. So it's going to be 10 e to the j 60. So it's going to be the polar format of that. And if this one and this one here are the same, as I said, that j e to the power of j theta is just cosine theta plus j sine theta, and the same here. So if I substitute this one in this one, I will get this one. So if I do that, I will get 10 times cosine theta plus j sine theta, which is going to be 10 cosine 30 cosine 60 plus j 10 sine 60, which is the same as what I have here. So you can see these are all very similar together, and we can convert them very simply from one to another. So let me go ahead and write all the format that we have up to this point. So if I want to write them, so the very first type I can write it is gonna, the first one, z is gonna be x plus, so it's a rectangular format. So if I'm writing, so the first one is the rectangular form, which is going to tell me the z is going to be x plus jy. So it's the first form. The second form is the polar form, which tell me the z is its magnitude and the angle it has. Then I have exponential form, which is going to tell me the z is going to be the magnitude of the z e to the power of j theta. And the very last form, so it's going to be in form of sine and cosine, cosine and sine form. Or in other words, they call it the Euler form, but I don't want to go there. But so this z is going to be z cosine theta plus j z sine theta. And you can very easily see that you can convert them to each other very easily. As I said, the x is, as you can see here, x is the z cosine theta, y is the z sine theta. So if you substitute x and y here, this one this is what you're gonna get. The very last equation you're gonna get. Substitute that in this one. The same also you can get the magnitude of the z is gonna be x squared plus y squared, and the theta is tangent square of tangent inverse of y over x. So these are the form of the complex number we have. And when we are doing the calculation, if in our calculation, in our mathematics, if we are adding or subtracting complex number, use form 1 or form 4. So I'll write them here. So to add or subtract, use rectangular or this one, cosine sine form. Use rectangular form or cosine sine form. So to add and subtract, do that. To multiply or divide, use polar or use polar form or exponential form. And I will show you that why it's much easier to do that. So previously I show you why it's very easy to add and subtract using this polar, using the rectangular format, or this one. You just add the add all the I would say the real part together and add all the imaginary part together. Now when it comes to actual to times or divide, it's much easier to do it with either of these two methods. I will show you why. So assume I have, again, assume I have Z1 is 10 with angle of 60 and Z2 is 5 with angle of 45. And now I want to find, do some arithmetic calculation on that. So this time Z1 times Z2 is going to be 10 with angle of 60 times 5 with angle of 45. Now let me convert them to the to exponential format. So it's going to be very easily. So it's going to be t e to the power of j 60 times, and this is going to be 5 e to the power of j 45. So I convert them. Now it's a very simple calculation. So you just to do that, so it said 10 times 50, so it's going to be 10 times 5 times e to the power of j, and you just add this angle together. It's going to be, or in other words, it's going to be j60 plus j45. So you will see that it will become that as 50 e to the power of j and 105. So see, it's much easier to do the multiplication, to times them in the polar format. Similarly, the division, if I go ahead and remember the last time when you want to divide, I had in the rectangular form, I had to go and times with the z2 star times and subtract with z2 star and do all those calculations. Now look at how easy it's going to be in this format. So it's going to be 10 with angle of 60 with 5 with angle of 45. And write it. Eventually, you don't even need to write it like that, but at the beginning you can write it like an exponential to make it easier for you. So say it's 10 e to the j 60, and it's going to be 5 e to the j 45. So you go ahead and look at that. So it's going to be 10 divided by 5, and then this is going to be sorry, it's going to be j60 minus j45, which is going to becomes 2 e to the j15. So you can see very easily you can do the um, multiplication or division using the polar format. If you want to add them or to add or subtract, again, it's much easier to do it in the as I said in rectangular format. So again, if I want to add z1 plus z2, I would say that what I have is going to be 10 with angle of 60 plus 5 with angle of 45. And it's not easy to do it this way, so I'm going to convert each of them to rectangular format. So this one, I know that's the 10, and then it's going to be cosine theta. So it's going to be 10 cosine 60 plus j 10 sine 60. So it's going to be the first one. And the second one, the same, is going to be 5 cosine 45 plus j 5 sine 45. And then easily I can come here and add the real part and the imaginary part together. So I can say that it's going to be 10 cosine 60 plus 5 cosine 45. These are the real part. So 10 cosine 60 and 5 cosine 45 is the real part plus j, and then the imaginary part is going to be 10 sine 60 plus 5 sine 45. And then can do the calculation. And if I have done everything right, it should comes out as 854 plus j 12.2. So you can see that is if you want to multiply or divide, just use the as I said, the polar format or exponential format. If you want to add or subtract, convert them to the rectangular form and do that. So if I want to put it in very again, if I want to put, assume I have the z1 is going to be z1 with angle of theta 1, and I have the z2 it's going to be with magnitude of z2 with angle of theta 2. So if I want to multiply them, so z1 multiply z2 is going to be z1 theta 1 times z2 theta 2, which eventually you will escape this part. You can write it as the exponential, and eventually you can escape it. You can just ignore it, but I will do that. Z, so it's going to be the z1 e to the power of j theta 1 times z2 e to the power of j theta 2, and then if I go just do that, it's going to be z1 times z2 times e to the power of j theta 1 plus j theta 2, which is become again z1 times z2 times e to the power of j theta 1 plus theta 2. And if I rewrite it back into this format, the magnitude is z1 times z2, and the angle is just simply theta 1 plus theta 2. So if you multiply z1 and z2, just you multiply the magnitude and add the angle. As simple as that when you are doing in this form. Similar for if I do the z1 divided by z2, what I have is the z1 with angle of theta 1, and then z2 with angle of theta 2. So I write all the middle step, but eventually you don't need to do that. We will jump to the very last step. So I will write it as exponential. So it's going to be z1 e to the j theta 1. It's going to be z2 e to the power of j theta 2. And then if I do that, it's going to be z1 divided by z2 e to the power of j theta 1 minus j theta 2, which I can write it as a z1 divided by the magnitude of the z2 e to the power of j theta 1 minus theta 2. And then if I write it as this polar format, so it's going to be z1 divided by z2 with angle of theta 1 minus theta 2. So eventually you can skip all these middle steps when you multiply them. Say, okay, I multiply the magnitude and add the angle. When you divide them, you divide the magnitude and subtract the angle, and this is how you do the how you will do the multiplication or division. To add and subtract, just simply convert them to the rectangular form and add them or subtract them, similar to add all the real part together and add all the imaginary part together. Or if it's subtract all the real part from each other and subtract all the imaginary part from each other.